Hey guys, so I'm going to try my best to have us do 2 lesson videos because I'm not going to be there for the rest of the week. So I'm going to do the best that I can, and I apologize if these videos are a little bit long. I just want to make sure you guys are understanding what to do. So today we're going to be working on this box and whisker plot assignment. So again, 2 ways that you can access it. You can either access it online, or if you want, the sub should be able to pass out the printed version of it. So today our goal is going to be to understand how to create and interpret box plots, because box plots are actually a really big fundamental visual key in looking at data. And so we're going to start with hopefully some things that you remember. So the first intro asks you to find the mean and median of the following numbers. So I'm just going to go ahead and start with set 1. So to find the mean, you're just going to add up all the numbers. So 1 plus 11 plus 21 plus 31 plus 41 plus 51 plus 61. And then you're going to divide by how many numbers there are. So it looks like there are 7 numbers. So we're going to divide by 7. And so when we do that, we should get 31. So this is our mean. Okay, so our mean is average. So you add all of the numbers up and divide by how many you have. The median is our middle term. So if we look at our numbers here, we have 1, 2, 3, 4, 5, 6, 7. So the middle one would be 31. Now remember that with median, you want to have the numbers in order as well. So you want them from least to greatest. So if you don't have them in order, then you're not going to be able to find the median. So I'm going to have you guys pause the video and do set 2 and set 3 to find the mean and median. All right, so if you did this correctly for set 2 and set 3, you would find that the mean and the median for both of these is also 31. So no matter what, it's going to be 31. Okay, so here's just some information that you need to know about box plots. So with a box plot, it gives you 5 key numbers. First is your minimum, which is the smallest number, then your maximum, which is the largest number, your median, which is your middle number we just learned, your quartile 1, and your quartile 3, which we'll talk more about, okay? So if we're looking at this example, we have 11 data sets here, and they want us to first find the median. So what we're going to do is we're going to add all of these values up and divide by 11. So I'm not going to type this out, but we're going to add 5,000 plus 11,000 plus 19,000, et cetera, et cetera. And if we did this correctly, we should have a median that is equal to 36,000, okay? And so remember our median being the middle value. Oh, and I'm sorry, I just described how to find the mean. So the median is the middle. So if we looked at these in order, 36,000 is the middle, okay? So to find Q1, you find the middle of the below data set. So here's the 5 numbers that are listed below. And you can see that the below data set, the middle of the below data set is the 19,500, because that's the middle value, okay? And that is your Q1. And then to find your Q3, you find the middle of the top half. So here's the top half above the 36,000. So the middle number there is the 42,000. And so the minimum and the maximum, so your minimum value is your lowest. So our lowest value here is 5,000, and our maximum value here is 89,000. So those would be our 2 other numbers. So we just found our 5 key pieces of information that we need. We have our min, our max, our median, which I spelled wrong up here, and then our quartile 1 and our quartile 3. So now what we're going to do is we're going to actually create or draw a box plot. So this is a little bit hard to do digitally. So I am going to be pulling up the answer key so that you can visually see what this looks like. So you can kind of follow along. So hold on just a second. Oops, this is not the right one. Here we go. Okay. Okay, so here is what the box plot looks like. So what you're looking at is you have the bottom, which is the minimum. Then you have the first part of the box, that is your quartile 1, which was the 19,500. Then you have your median, which is the 36,000. And then you have your quartile 3. And then you have your maximum. So you'll notice that the box basically makes up the quartile 1, the median, and the quartile 3, and then the minimum and the maximum make up the whisker part, or the end of the box plot part. Okay, so now what I want you to do is I want you to pause the video and I want you to do the practice of the next section. So when we're looking at the next section, it's practice it. So you can use this with your teammates, and you're going to go ahead and look at this data set, find the minimum, the Q1, the median, the Q3, and the maximum, and then try to create your appropriate box plot for it. Okay, and so since these are notes, I am going to show you the answer key for this. Hopefully you got it right, but if you're looking at it, we have our minimum of 35, our Q1 51, our median 64, our Q3 66, and our maximum 70, and this is what your box plot looks like. Okay, so now what we're going to do is we are going to analyze your box plot, and what does that mean? Okay. So when we are analyzing it, we can analyze it in a couple different ways, but we can first find out if there's any outliers. So outliers are basically if there is possibly a number that looks like it doesn't belong. So you might notice that your box plot is skewed one way or the other because of an outlier. And skewed means that that box and the data are all on one side, or all on the left or all on the right. We can also see how it's dispersed, so basically how all of our data is grouped. So if we were looking at Nick's data, which was from the first problem, we would notice that 25% of our numbers are in this first section, 25% are in the second section, 25% are in the third, and 25% are in the fourth. Okay, so this allows us to kind of analyze, so we can say that 75% of surveys said that they have less than $42,000 of student loan debt when they graduate. Okay. So if Nick wanted to include information about the bottom 25% of respondents, what could he essentially say? So if we were looking at this, we could say that the bottom 25% of respondents owe less than $19,500. And are there any outliers? I probably would say that there wouldn't be, just because it's not that skewed over. But there is a higher number of the 89,000. So you could argue 89,000 is slightly higher than most of the data. So this could be considered an outlier. Okay, and so again, your data, you would want your data to be essentially like a little bit bigger or further away than most information. Okay, another thing that you can also do is you can figure out your range and interquartile range. And so your range is basically the difference from the minimum and maximum. So in this case, we have 89,000 is our high and our 5,000 was our low. So if we were doing this, then 84,000 would be our range. And then if you wanted to do the interquartile range, you would take your IQR 3, which was the 42,000, and minus your interquartile 1, which is the 19,500, and that would give you 22,500. And why these are important is because then you can see how widely diverse or how widely spread your data is within your data set. Okay, so because I'm not here, we are going to skip this activity, create a box plot jigsaw. If we have time when I get back, we will complete that. But for now, this is your note page, and I'm going to have you go ahead and work on your application of this next.